I saw 30 people.
Yeah,
that could potentially attend. We know that the reality may be quite different.
We'll see. It doesn't matter.
But I see 11 currently.
Okay, announcing it on Twitter now. Okay. Okay, guys. So let me share the screen. And let's kind of start. So everyone, welcome to our first Java panel on AWS on Java or AWS on or Java on AWS. Like, what's the appropriate name for this? Like, I understand that a lot of stuff in AWS runs on Java, and that Java is in a core of many systems, many services that we have now. So it's not only about user experience in Java in AWS. It's also about everything that is stable, that works so good for all these years and doesn't fail. Like, it's super fast and all these things that we expect from Java. And what the discussion that we have today is a product of some kind of a new youth, that new energy that is brought to Java in the last couple of years, and we see that Java is expanding again. You know, like, we have Java every 6 months, new release of Java. We have also some new energy in AWS, like that came from people like Mark, who's today with us. Like, people are kind of really talking again about stuff and showing that things are easy, that things are good, that in some super easy way you can build some super stable services. So everything kind of like is getting back again, like for Java. And of course, like, now we have a lot of people who are really excited about that and talk about that. So especially I want to point to two of our guests today, Vadym, who is like super energetic. Like, really, I see you everywhere. Like, on every possible conference, there is a talk about serverless Java now, and your presentation is kind of everything. You know, if you want to learn about serverless and Java, it's there, like, from beginning to the end, like all the frameworks, everything. You know? And also, like, Serkan from Tundra, like the company who is kind of from the beginning having Java in everything, like from the special runtime to do some stuff before others were focused on Node.js or other languages, which are kind of serverless native, other stuff. Like, you were always promoting Java, and now you have something which is I don't want to say super again, but it's just like something that we would like to see and discuss here. Okay, so I'll give you a couple of seconds for every single one of you to introduce yourselves, and then we'll go back to our topic. Okay, so let's start with the Mark. Mark, please.
Hi everyone. Nice to be here and have the invitation to join this panel. It's really fantastic to be talking with you all. Yeah, my name's Mark Sales. I'm a specialist solutions architect at AWS. So I speak to a lot of customers about AWS Lambda predominantly, and in particular, I have a real interest in Java and talking to customers about how they can bring their Java applications to Lambda. And that isn't always easy. So I listen to a lot of customer problems, and I just really try and dive deep and understand the pain points and try and do my best to research new ways to alleviate the problems. So yeah, that's me.
Okay, Serkan.
Hello everyone, this is Serkan. I am the co-founder and CTO of Tundra, which is serverless monitoring, debugging, and tracing solution focused on AWS Lambda platform. And I am also AWS hero, and I'm also the creator of the Merlock, which is a tool that I'm going to talk about today. And I think I have been in serverless era since 6 years, and mostly focused on the Java and the Node.js runtimes for the servers, and just working on the tracing and the debugging capabilities on serverless to pinpoint the issues people are facing. Yeah, happy to be part of this panel. I have been waiting for such panel for a long time. Yeah, thanks for everyone to join this panel. Yeah, thank you.
Vadym.
Yeah, hi, my name is Vadym. Yeah, thanks, Goran, for the invite. I know all of you virtually, and it's nice to meet again. So yeah, I have this passion to Java. I wrote the first program in the last century, which is also the sign how old I am. But just it was the programming language I always used primarily, and in the last 5 years, at my employee AP Labs, we migrated our data centers from the to AWS, but all the new stuff we try to do serverless, because we really believe in the vision, just to focus on the business logic. And we had and still have a lot of very clever Java developers, but then serverless challenges all that assumption that we have with the long-running applications and Tomcats and natives of this world. And it was nearly impossible to onboard the people to use Java, at least for the high frequently used, I would say, public-facing application with a lot of requests. That's currently the challenge, because the community is great, the Java is great, GVM is great, everything is great. But we see how this innovation sometimes, challenge everything, and you need to embrace the community and probably improve the stuff. But that's probably the topic we'll be talking today.
Well, we'll talk about that, of course. Like, let's see what are the topics for today, and let's see how can we jump and solve some of the stuff, and make. And we have to cross that bridge, like between the what's on the table and what's really in use, and what's really helpful and what's not. There's a lot of talk, and then so let's see what's really important. So these are the topics for today. Like, there's gonna be like maximum 10 minutes for every single topic. So like we can't be boring. We have to be super efficient. So I would like everyone to say, if black and white stuff, like I like it or I don't like it, or I just it won't cost you anything if you say something really honestly. I assume everyone except Mark can talk freely. Mark works for AWS, so he can't say everything, and not because of course he's like, it's not because it's forbidden, but it's more about like stuff that are in development that he knows that will improve, and there's a lot of people involved and a lot of processes, so we won't push too hard. So let's start with the developer experience, and I asked Serkan to show us one of the tools that improve this developer experience, but this topic is huge. So once he shows us like this thing, let's say, please say something about like what do you see as the biggest problem, or if there are no problems, or what do you see like are the roads that we have to go to solve some of the stuff, or anyway, like whatever you want to say. Okay, so Serkan, please show us the Murloc. Okay.
Let me share my screen. Just give me a sec. Okay, I'm just sharing desktop too. Okay, so just before diving into the demo, let me just talk about what is Murloc and what is the motivation behind the Murloc. So in Tundra, as you know, that we are a serverless monitoring tool. We are heavily, our architecture is heavily based on the serverless. So almost 100% our architecture is serverless. But the problem is that while we are developing, and also our code base is mostly written in Java, but we also have the Node.js and Python lambda functions for the user-facing lambda, especially. But the challenge we are facing while developing Java-based Lambda functions is that local debugging over mock service is not easy in terms of the setup and the reproducibility of the issue. For example, let's say that you are developing a Lambda function and probably you will want to test the Lambda function without need to deploy the remote AWS Lambda environment, because you don't want to deploy the application after every change. For example, we have seen that, and in Tundra we are hearing from our users that they are mostly just when they just apply a change to their Lambda function, they just edit, for example, the console log statement and the system out print line statements around the code, and then deploy the application and that checking the logs, and then if there's a still issue, they are just repackaging and redeploying again. And also we were doing the same thing in Tundra, because it is not easy, especially if you have a very big event-driven architecture, it is not easy to set up everything on your local and mocking everything on your local. And so that was the reason and the motivation why we have built Merlock internally. And since our code base is mostly written in Java, Java was the first choice of us to support the runtime, but also the Node.js runtime support is on the way. So the problem with the remote debugging, especially for the Java runtime, is that because of the nature of the Java debug wire protocol, there are a huge amount of data is serialized through the network. So let's say that you are, for example, I am locating in Turkey, and let's say that my Lambda function is deployed to US West to the Oregon region, and because of the physical distance, when I want to debug my Lambda function remote, and because of the nature of the Java debug wire protocol, there are many requests coming from requesting to there and then coming to responses. And also the Java debug wire protocol is turn-based, so there are many requests and responses sent sequentially. So because of that reason, debugging the Java application, not just for the service application from remote, is not a very user-friendly, developer-friendly way. So that was the reason that why we were looking for a way to debug the Lambda, to develop and debug the Lambda function on local, but still the Lambda function will be part of the remote architecture. So let's say that you have queues and the topics on the AWS Lambda, but let's say that, and also there are other applications. Let's say that you are developing a single Lambda function and you only focus on that Lambda function. So you don't want to run or deploy the other Lambda function. So with the help of Merlock, you just run the function you are working on it on your local, and then you are able to debug and hot reload the Lambda function without packaging and redeploying to Lambda environment. And with the help of Merlock, that really helped us to improve our productivity while developing the service function, because before the Merlock, what we were doing is that some time to time we were just adding the logs to the Lambda functions and packaging and deploying, and especially for the Java function, there are many dependencies, and sometimes you are uploading about 50 or 60 megabytes of jars or zip files to the Lambda, and it took some time because of the network latency and also because of the packaging delay. So local debugging experience really helped us to overcome such issues.
Okay, so you brought the environment and everything, like the state of memory, everything. You brought it to your local, like whatever that is, instance of.
In fact, what
Docker or something.
Merlock is doing is that, let me just talk about through the architecture, maybe, so that will be easier for everyone to understand how the Merlock works. For example, here, there are three components in Merlock: the gatekeeper, the broker, and the Lambda runtime. And the broker is responsible for managing the communication between the gatekeeper component and the local Lambda runtime environment, Merlock local Lambda runtime. So at first, while you are using the Merlock, you are just setting up the broker on your own AWS account. For the setup part, you can just run the AWS a CDK application to deploy the broker to your own environment on your AWS account. And then there's also another component, gatekeeper. So basically, gatekeeper is a wrapper layer for your Lambda function. So what it does is that when there's a request coming to your Lambda function, gatekeeper just checks whether there is any connected local runtime to that Lambda function. If that is not, it just forwards the request to the real handler. And if that is there's a connected Lambda runtime to your local, just forwards the request to your local Merlock Lambda runtime through the API gateway through the broker. So and also, so gatekeeper not just sends the payload, the request payload to your local, also just sends all the environment variables, including the AWS IAM permissions. So Merlock Lambda runtime here is responsible for managing, spinning up, and running the Lambda functions on your local in their sandbox environment. So they are isolated from each other, and also since they are using the same environment variables with the removed real Lambda function, so you are using the same credential with the real AWS Lambda environment.
So it's a real fake of the original. It's the same code, same environment, same credentials. It can react as the real one deployed. That's interesting.
But let's say that you forget to add some permission to your configuration. So and you will get the same authentication, same permission error on your local. So because they're just using the same things. And also another challenge is that the network connectivity. So let's say that your Lambda function is accessing to RDS database running in VPC. Currently, Merlock doesn't support doesn't have any out-of-the-box support for the network, but that will be there eventually. Currently, the suggested way is that just have a VPN connection from your local. You can just set up a VPN connection. There are various ways. So once you have a VPN connection from your local to the resources behind the VPC, you can just use Merlock still on your local. So this is basically how the Merlock runtimes runs. I think there are also other details, but I don't want to talk about right now because we have some limited time. So if you don't stop me, I can talk about Merlock house. So I think that is enough for the architecture of Merlock. If you have any question, I'm happy to answer right now.
So a couple of questions like we have in chat now is like regarding the safety of the solution. How do you feel about that? For like, do you see that it's for production in any way? Should we do debugging in production?
In fact, it is not suggested. By the way, yes, you can use it on production, but that is not the suggested way because you are running the application on your local, so you don't want to access the production from your local. So, but there are some ideas to be able to use Merlock for the production cases, but still there are just idea. But currently, that is not a suggested case to use the Merlock against the production because we don't want to access the production resources from your local. And also from the security perspective, since all the source code and the runtime codes and the plugins is open source, so you can also check it out, and all the contributions are welcome. So basically, you are deploying the Merlock to your own AWS account. Currently, there is no SaaS solution. This is just open source project and waiting for contribution from the all servers community. And yeah.
So in that regard, your corporate data is never leaving your account or going to a SaaS providing, just staying within that AWS account and then going to your machine.
Yeah, exactly.
So how do you feel, guys, about this? Like, do you? I mean, especially you, Serkan, do you use this that you just created, or is it like is it really helpful for you, or like or do you see that maybe you have a need for this only if you have problem, and if you have problem, maybe you would need like some kind of a dump of that kind of environment that or that state that happened when the problem appeared. So how do you relate to this? Like when do you think this is useful in development or debugging or like testing or error handling, or in which phase of product use is this?
Currently in Tundra, the malloc gatekeeper is already available for every Java Lambda function. And when there's no connected local malloc Lambda runtime, the gatekeeper just forwards the request to original handler. So the Lambda function runs as is when there's no local Lambda runtime connected to it. So the gatekeeper for our development environment, the malloc gatekeeper layer is added to all the Java-based Lambda function right now. So the cases for us is that the first case is debugging, because we have serverless debugger, but the problem with the Java runtime, as I said, that remote debugging is not for Java. So for example, we are deploying the Lambda functions to US Phase 2 region in Tundra. And while we are trying to debug the Lambda function and the Oregon region, because of the physical distance, it is not very useful or efficient to debug the remote Lambda function. Because let's say that I just put a breakpoint and then it took a few seconds. And then if I want to just evaluate some expression at that point, it can just take 5 or 6 seconds, depending on the network conditions and the Lambda function memory size. So this is not super helpful while you are debugging Lambda function on remote. So especially because of the nature of the Java debugger by protocol. So that is the reason that why we start looking for a solution to able to run the Lambda function locally. But debugging is not just the only reason for the malloc. The another reason is that once we identify the problem, and when we just try our fix without deploying to the real AWS Lambda environment, we just want to debug and test the Lambda function on local with the applied changes. But the problem is that let's say that you have many queues and Lambda functions just interacting with each other through queues. You want to provide the sample request to your Lambda function locally. Yeah. So that is not easy every time. So when you use malloc, you don't need to provide any sample payload or something like that. You just trigger your business flow. And since the Lambda function is a part of the business flow, when the malloc gatekeeper is attached to that Lambda function, just forwards the request to your local. So you can just debug on your local and then you can continue. And another case is that, for example, let's say that your Lambda function is behind the API gateway and there are 30 seconds limitations for the API gateway. So with the help of malloc, you don't want to bound to 30 seconds limitation of the API gateway. So let's say that your API gateway just triggered the Lambda function and even the API gateway timeouts after the 30 seconds, still you can continue debugging your Lambda function on the local, because you are running the Lambda function on your local, you are debugging the function on the local. So you are not bounded to the timeout limit of the API gateway here. So this is also another advantage of using the malloc for our case.
So guys, Vadym, Mark, how do you see this? Like, do you think the debugging is the core missing feature, or some other stuff are you like more in a club that says, okay, we want faster deployments, or we're in some other club? What's your club?
I guess I would definitely be interested in this when I was doing like lots of fine-grained IAM changes. This would be really helpful to understand, what sort of IAM changes I needed to make. If I was making really fine-grained changes, it would help me to iterate quickly. It would I also do write applications where I am in a chain and producing, high quality requests isn't always easy. So I could definitely understand, just as a nice way to produce, valid inputs to put into unit tests or other things like that. So yeah, I'm definitely interested in trying it. And also I'm seeing more and more complicated applications coming to Lambda. So people doing, serious cryptography and serious modeling. So I can see the benefit of debuggers becoming more and more. I think there was definitely a time where people were writing, glue functionality in Lambda functions. I think people are now understanding the value of Lambda and bringing larger and larger systems to Lambda. So I think these sorts of tools will become more and more useful over time.
Okay. So from my opinion, sometimes if you have the problem in the business logic, you would like to figure out quickly what it is, then deployment takes time, and then it's not a solution to put everywhere system out println after each row just to figure out. So you need all these debugging capabilities, real debugging capabilities that they look into the stack.
Is this just because you're used to that, because you're doing that for years, or and you want it now again, or why is it so?
I mean, debugging is natural for everybody which develops Java, and that's okay. Something that's of course you need to write your tests and figure out it earlier, but sometimes it's just you have the problem. You need to figure out. You need to do the stuff locally, change locally, and see how it behaves also locally. So there is quite a good mixture. I don't think that it's useful to test cloud locally. All the limits or quotas of the services, that's not the solution. It will bring nothing. That's why I'm a bit skeptical if I hear can I grow API gateway timeout. Okay, for that use case, yes, because it's just I'm interested in looking to the business logic. But generally, only for those cases, some quick tests or something doesn't work. But on the other side, I see that the cloud deployment also becomes quicker with only diffs being deployed and not the whole stuff. But still, it's about minutes. And if we will talk about GraalVM, then that's another set of waiting time. So that's sometimes you need to do the stuff quickly, but it should be for me. It should be kind of limited scope.
Okay. So some accelerate brought some speed changes, and like of course the CDK also has its hot swap mode now, so you can just like that click and you're done. You have that. Of course, you have to use that in production to make an instance of that. Otherwise, it's like what the hell? Like what kind of problem you're solving? Like so, we need tools to solve some problems in development and testing, but we also need some tools to fix some problems in production, because code build is slow, because it takes a lot of time to build a new application and deploy it using CloudFormation. Of course, you can maybe use GitHub Actions or stuff, so which are not completely natural to AWS, but with CDK hot swap and SAM accelerate, you can get that things in production in a millisecond. So is anyone using SAM accelerate in any way to get some new stuff that would maybe share with us? I didn't use it. I read a lot. I'm maybe a more CDK guy than SAM guy, but I see that some of the stuff is really great, like packing packing libraries in a layer, so you can just deploy your this some of this stuff is really changing the developer experience. Mark, you are mute.
I have to admit that I haven't tried it yet. So too much happening in this space, and it's not something I've tried yet. But yeah, I guess I'm on the CDK side as well. And yeah, definitely interested in trying these new tools, but time escapes me.
By the way, I am also interested with the SAM local integration in terms of the malloc, because I don't want to reinvent the wheel to run the functions locally, especially for the non-Java runtimes, as I am not familiar with it. So I am thinking of replacing the local Lambda runtime with this SAM local to run the functions on the local. But still, there will be the component interacting with the broker. But I think, and I will eventually replace the Lambda runtime with the SAM local, I think.
That's good. So let's go to the next topic. Okay.
Maybe I can just give a few minutes demo to show.
Oh yeah. Okay.
Okay.
You have a couple of minutes only.
Yeah. Okay. So I have prepared a sample to the application. Just you can find the code. By the way, so I think I'm not sharing the screen. Oh, okay, I'm sharing the screen. Okay. So you can find the application infrastructure, the CDK infrastructure, and the code base in the GitHub repository. So what we are hearing is that there are the AWS Cloud Front and the API Gateway, Dynamodb, and the Lambda function. So basically, when you just refresh the page, the front end just sends a request to Cloud Front, and it just forwards to the API Gateway, and then it triggers the Lambda function. And also for my local, I just use the IntelliJ IDE plugin for the Merlock, because for the IntelliJ users, it is the suggested way to integrate the Merlock to your local. So you can just find the Merlock IntelliJ plugin from the JetBrains marketplace here. So when you install the Merlock IntelliJ plugin, and you just need to add the Merlock run configuration to your run debug configuration in the IntelliJ. And then for the configuration, we just need to the broker URL you set up with the AWS CDK application. So here I'm just using the custom domain support of the Merlock here. I just deploy the broker to my domain, to my own AWS account. And then I'm just selecting the module, which includes the handler implementation here. And then when I just run the Merlock configuration in the debug mode, you will see that there's a Merlock banner here, which means that the Merlock connected to your broker here. And then you can see that there are some breakpoint here for the list Lambda function. And when I just refresh the page, it will just hit the Lambda function eventually through the Cloud Front and the API Gateway. So let me just refresh the page. And then eventually I expect that the request should hit my local. Okay, the request just hits my local. As you can see that I can see the request here. And also when I just, for example, just evaluate the expression here, you will see that all the environment variables is coming from the real Lambda function. For example, these session tokens, these secret keys and access keys is coming from the real AWS Lambda environment. So you are using the same permissions with the Lambda environment. So let's say that I just put another breakpoint here. And then it also stops here. So you will be able to just observe any values like you are making any classical debugging on your local. Okay, I think the CloudFront tries something a few more times. Okay, so let's say that also another case for the Merlock is that just let's say that you just apply some local changes to your Lambda function. With the help of Merlock, you don't need to repackage and redeploy the application to the Lambda environment. So let's say that I want to list or to do items according to their start times. Currently, they are just listed randomly, whatever the Dynamodb returns to me. So let's say that I just want to debug I just want to just sort the to-do items before returning from the Lambda function. Let's say that I'm just using their creation times to sort key here. And then I just changed the implementation here. And then when I just reboot the project, so eventually you will, okay, I think okay. So it just hits another, just tries to reload, but seems that there's an issue but still this will work. So I think the ID just cleans up the target folder and then recompiles the application here. So still the application should work here. Let me just clear and then trigger the lambda function again. Okay, just hits my breakpoint again. And when I just let it go down, and you will be able to see that the items are sorted now. So they are seeing differently. So what I'm doing here is that when I just edit new code here, when I just rebuild the application, Malloc automatically watches the class path. So when there's a change in the class path, it just finds the associated lambda function, which depends on that classes that changed classes, and then hot load that lambda function on your local. So when you trigger your lambda function again, since there's a fresh lambda application on your local, your local lambda function will run with your local changes. So with the hot load feature, you can test your lambda function locally without deploying to your real AWS Lambda environment.
There's a question in chat about the support for GraalVM, but I assume that any language with the debugging capabilities would be, sorry, any runtime with the debugging capabilities at the end would be kind of debuggable in this same way. GraalVM, you can debug GraalVM now, so one day, hopefully.
Currently, because of the limitations of the gatekeeper right now, GraalVM is not supported right now, but we already talked about before the meeting. There are some ideas coming from the Herald. I think I can give his name. So eventually I will replace these components with a more runtime agnostic way. So when I just do that, I will be able to wrap the GraalVM application running on the Lambda environment. So that will make feasible, and that will make feasible to debug the GraalVM Lambda function on your local. But currently, unfortunately, it's not supported right now. But that is not the limitation of the Malloc architecture or the Malloc approach. So that is the limitation of the current gatekeeper implementation.
I know that IntelliJ has an experimental GraalVM debugger, and Red Hat are also working on some functionality as well.
Yeah.
It'd be cool to see all this come together in the future.
Yeah.
Serkan, I have also one question. You told about, so API gateway Lambda is synchronous way, and you told it's not possible if you put something into VPC. Will it be possible if I invoke Lambda synchronously, like with DynamoDB streams, or I have SQS and then Lambda Polar, something like this? Can I debug those functions?
Yeah. You can debug any kind of Lambda function. Let's say that your Lambda function can just put an item to DynamoDB, or maybe your Lambda function can be triggered from the CloudTorch, from the DynamoDB streams, from the Kinesis, or whatever the Lambda triggers works. You can use that type of Lambda integration with the Malloc, because basically we are just Malloc just forwarding the request to your local.
Well, there's going to be a lot of debugging, and of course, people will not test anymore, and it's just start debugging just like they did for years, and everything's going to be fine. So let's go to the next topic. So Java 17, 19, 21, whatever, like, how do you guys feel about AWS not releasing support for Java 17 for a year, and then releasing Corretto 19, and then kind of everything is super fine, so we are going to be happy now, and then at the same time, like code build support for Java 17 is like, it was 8 months late or something, and so I was really expecting, because Mark was there, that on the day that Java 17 was released, that we're going to get some Java 17 runtime for Lambda, but unfortunately that didn't happen. But is it really important? Is it really that important that we really need that Java 17 support in Lambda? Now, of course, Mark, you did a lot of effort to show us that it's possible to run Java 17 in Lambda with a special runtime. So it's obviously some kind of, it feels like it's important. So what do you guys think about that? Is it really important, or?
Yeah, we talked about several minutes before. It's not here to blame. There are reasons for that. So I also assume that AWS is doing everything to do this, but especially under the consideration that Java will release long-term versions now each 2 years and not 3 years, then the next year Java 21 LTS will come. And then if we don't even have support for Java 17 for Lambda, then it's kind of, yeah, maybe it's kind of broken experience, and then the people will start exploring. So at least GraalVM support Java 17, they support long-term releases, then they will probably do custom runtimes or Docker with the newest version. So of course, if you have choices, that is super, but I think also that the goal and the aim of AWS was also just to reduce all these cold starts, even with the newer version. As far as I know, there is not too much difference between Java 8 and 11 in terms of cold starts and in terms of other optimization for the serverless, but maybe we have to see what could be achievable with even 17, but we don't have the possibility. It's interesting to see that Coretta was released 19 on the same day as Java 19 was released, but not for the serverless world. And I think if AWS would like to embrace Java community, and I see that efforts, yeah, then they need to be just to align their roadmap on that. Better.
But do you need it? Do you really need Java 17 in serverless now? Honestly, just say.
So I really love all that cool language features like pattern matching and the seal. So that gives me a better developer experience there. It makes me productive. We talk about the frameworks on top of that. It's a different story. But it's really interesting to see what's going on. I will look if the Loom will become something useful for the serverless world. Maybe in case you are using relational database, which is kind of another tricky questions that maybe, but all these Java features, I love them. Yeah. So that's probably I don't need all of them.
Multi-line strings with JSON, copy-paste JSON into Java. That's one thing.
Return HTML response to the API gateway. But no, that's probably not that pattern matching. There are a lot of things, syntactical sugar, this project Ember and all that stuff. It's just everything. Everyone is crying Kotlin is way beyond Java for that stuff, and Java is just releasing that stuff. So I mean, it will be also interesting what runtime will give me in terms of also cold starts and so on, and maybe I can use all that stuff to build smaller GVM. I don't know. It's not what was released, but anyway, with JLink and JDepth, it's possible generally. Maybe that will open the possibilities which are not available in Java 11.
Yeah, Mark, so, you did a lot of effort to put Java 17 on serverless. So why did you do that? Because it was fun, or do you see that there's a need from clients?
Hey, I was the first one wanting to use records. I think I'm just like everybody. As soon as you get a new Java version, you're looking at how you can improve your source code of your applications and take on the new features. And I'm exactly like that. I'm probably not the type of person who's going to be looking at Loom. I think that's probably outside of the serverless, but there was a lot of really cool features in 17 that I want to use. So yeah, definitely I was very interested in looking at how I could use that early on Lambda. So I'll grab a link and I'll pass it over to you so that others can see that we have an approach where although it's not a managed runtime, there's a way that you can use Java 17 on Lambda today. And I'll make sure that the GitHub repository is shared. But still, I still want the managed version of that as well. I want the contract of AWS Lambda. I want the runtime, and I want AWS to manage it so that I don't have to do that.
We want that 10 seconds for free that we get through interface. We want that power during that init phase, because in Java we still need that to cut the cold start. Okay.
Yeah, absolutely. Yeah, I'm eager for that to be released as well. I can't wait.
Yeah.
Is there any cold start improvement between the Java 11 and the 17? Have you ever observed such improvement, Mark? While trying?
I haven't done a huge amount of research, to be honest. Not that I've noticed in a way that's been significant compared to
I
other
wouldn't
features.
say. I wouldn't say too. Yeah, not really. Yeah, not really. But we'll see other stuff coming with Java 17 may improve that. So like we see that there is a difference in Java from Java 11 to Java 17, and we see that all the frameworks, everyone is kind of jumping into Java 17. In my case, I have a situation where I have the same application running in Quarkus, created in Quarkus, that is running the same code runs in lambda, in Dockers. So I can deploy it in different scenarios, even in Kubernetes if I want. So it's because lambda is not supporting Java 17, we are still using Java 11. So it's kind of not allowing us to go to the next step. So I would say that there are some it can stop you, but it's maybe not really that big blocking issue that we can run Java perfectly well in Java 11 today. So Serkan, do you see that clients are asking for that, or is it a hype? Or
actually, there are not many requests asking for the Java 17, but we have seen that the customers are moving from Java 8 to Java 11, and especially there are also some easy way, especially for the tools like Tandra, to integrate. For example, the AWS Lambda exec wrapper, for example, it is only supported at the Java 8 with the Java 8 Corretto and the Java 11 Corretto. So I think that is the best way, and that's the best time to move to Java 11 right now, because as I said, Java 8, there is no some of the features are not available for just pure Java 8 runtime right now.
Yeah, I see a lot of people, asking about, migrating to Java 11 from Java 8, but there's nothing really that makes me excited about moving from 8 to 11. Whereas 8 to 17, I think I get a lot more from a developer point of view. 8 has been around for a long time now, and I hope people are, looking to migrate. It's going to be supported on AWS for a long time, but I hope that when 17 is available, that people jump on that. I think it'll be real big improvement from developer point of view.
So Mark, we have no clear date, so we have no promises, nothing, and with that we're going to the next step.
Can we call your boss, Mark?
Yeah, sure. So the best thing to do
here live in studio.
The best thing to do is, the saying is never to complain about AWS where no one from AWS can hear. So jump on GitHub. +1 the issues on GitHub is probably the best, most effective way, or make it known on Twitter. At AWS support.
Wishlist.
Yeah, wishlist.
Yeah. AWS wishlist is not so bad. Yeah. Screaming on Twitter.
No wish was fulfilled until now, and I have lots of them, like data API for serverless V2, but it's probably the topic that Goran will be talking in Netherlands. Next week in person.
Yeah, of course. I mean, there's a lot of things that we need as developers, and of course, we're not going to get everything, but at least if we scream in some directions, maybe they'll hear us, and of course. So Prashant is making some comments about HTTP client and benefits with it. It's there's a lot of things. Maybe next time, maybe we can talk about HTTP client from AWS, which is not also in beta phase for 3 years or something. So God help us. So we'll see. Anyway, so our next topic is GraalVM. Let's talk about like just for a couple of minutes in terms of, are you excited about that? What do you see that's is great about that? Is it just removal of reflection and all the things that came with that, or is just or do you really believe in compiled to binary native stuff? So how do you feel about that, guys?
Probably, so GraalVM is a whole lot more that we probably will be talking in the serverless world, like, which is only ahead of time compiler. This is just language iterability. I didn't use that, but there are use cases that it can be really helpful. Yeah, but every technology is a trade-off. Yeah, and ahead of compiler is simply a different trade-off. But and of course we have this building time, but this is optimized for smaller packages, for quicker start time, and in the usage of more memory, which in the first, if you see this, that solves that sort of, at least I would say, cold start problems. Yeah, then you probably you won't have that warm time performance, because just-in-time compiler will perform better generally as a ahead of time compiler, but that's probably not a huge difference for short learning lambda functions. But in terms of cold starts, yes. But of course, the more dependency you use, then they should be GraalVM accepted, kind of, yeah, that you don't run into these reflection problems, and then so the whole stack should be GraalVM ready. And that is, I think, also a big challenge. And of course, all this compile time of, I have this between 3 and 4 minutes on my local machine with 6 GB. And if you have multiple functions, you have to scale your pipelines. That's also the question, how you will do this, because cold build is also not very quick. So there are different challenges. So probably GraalVM will not save the whole world, but for the hottest function that you really need it, if you only use small dependencies to AWS SDKs like Dynamodb SQS, then everything works. So at least in examples that I tested, and I think it's really exciting technology. I didn't see too much coming from Oracle in the last years, but this is definitely one. Yeah, but with different kind of challenges. And I saw that GraalVM now with 22.2, they have smaller packages. They reduce the size of 50%.
Compile time too, yes.
Yeah, and probably they will compile time will also reduce that the developer experience don't suffer. Then I think that the bridge can be better closed. So we can probably have a good mixture of. I have a dream that GraalVM will become kind of out of sync, that I'm dealing with Java, and AWS may decide, do I need native image of GraalVM? I'm not talking about GraalVM without native image. That's I know that it has its challenges, but I don't need to care. That's I want to write Java code. That's my dream. I don't
exactly. So you want AWS to compile it for us, test it for us, and then deploy it for us.
So of course I need to take care. I need to know that it works one time. Yeah, that bridge needs to be solved, because of course it may be that you run into runtime problems because of some dependency. But generally, I just want to deal with the plain Java code and not that infrastructure to build that stuff and all that. It's a bit boring. It's interesting in the first place, but if you try to scale with 100 lambda functions or a bigger organization, then yeah, it's a different story. Maybe somebody has other experiences, but I think for the hottest functions, you can optimize this that way with ahead of time compiler, of course.
Yeah,
Linux image, custom runtime, all that, not 10 seconds for free, everything, of course. Yeah, but I think, yeah, custom runtime needs also to be managed.
We want 10 seconds for free for every runtime.
It will be nice, but I think it's this kind of pinnacle on the
I definitely agree. I think the thing that I'm most excited about is, a really different performance characteristic, the very fast startup time, the difference in the memory utilization. I'm seeing, sometimes 8-time reduction in memory usage and still having the same, fast speed. And I'm not really seeing, a huge difference between peak performance on JVM or GraalVM native image. I think I'm seeing very similar kind of performance. So I don't think I'm really losing a lot with GraalVM, but I'm gaining a lot in the cold starts. And I've never seen a customer say, my warm starts aren't fast enough. That is not a problem with Java. Java is, exceptionally fast under load. And it's a very interesting characteristic of Lambda that it actually gets better the more load it's under. I think that's, pretty uncommon in computing terms. But the big problem I see with GraalVM is if I have an existing application, how do I know that I've configured native image in a way where I'm not going to get any runtime exceptions? And I think that's the area where I'd like to see more kind of content and more tooling from Oracle and others. With the latest version of GraalVM, you can now enable something called the Reachability metadata repository, which is a repository on GitHub, which is managed by Oracle, where they are working with Spring and others to collect reachability or reflection configuration, which is most commonly, for various libraries that either aren't GraalVM supported or are not maintained, or don't plan to add GraalVM support for maybe the next major version. So I think initiatives like that will mean that there is less issues and hard pain points when using GraalVM native image. I think initiatives like that will really help. I would love there to be a big hackathon to make the top 100 Java dependencies GraalVM compatible. I think that would do a lot to aid the adoption of GraalVM native image.
Mark, is there any tool that just detects the reflection codes from a running application to produce the configuration, to reflection configuration file for Graal?
Yes, so that is the GraalVM tracing agent.
Okay.
So you can run your application with the tracing agent and it will spit out all the configuration required. But that does assume that when you run your application, you are basically effectively exercising every path. That every path is executed so that every possible dynamic aspect can be found and produced. So it's not a trivial problem. There are tools out there, but things like having a good test suite would be really helpful. You can run the tracing agent with your test suite. You're probably covering a lot of your code with the test suite, and it will just spit out all of the config that you need. Again, more content and examples of how to do that is probably what the community needs.
But it's not just about like Java. It's a environment is a bit different. For example, like client certificates that you have in Java are not there. Like, so you have to provide some of the stuff, some extra stuff, just for things to work. So we need to test it in the real environment. So I had some idea that maybe if we can just deploy Java to AWS and provide some tests with it. So AWS would compile it for us, test it for us, and if all tests pass, so you deploy the next thing. Okay,
that's interesting.
That may also work for new versions. For example, if I want to jump automatically from 8 to 11 to 17, I don't care which. So if all tests pass, can you just move it up? And so we can have I would really like to have an application that would run forever. So if all tasks
and the upgrades are managed,
just upgrade my runtimes and go for it. Like, who cares? Okay, guys. So our next topic is one of the tools that would that's promising stuff like in Java world, and it's more about many different technologies that are coming in a different way. So it's all about making some kind of a snapshot of something and then restore it when we need it. So we can cut some of the stuff like a cold start. So my question for you is with all these technologies that are there from Java 8 and 10 or something, would you if someone can provide you with some of these solutions, would you still use GraalVM, or would you really like to stay with Java? Like, so my question is more about GraalVM, because it's kind of it's great, but it's aggressive. Just because when you hear what Mark is saying, what they're making repository, we need to make a hackathon, we need to do all of this stuff just for it to work, you know. So it's too much, maybe. So I'm just asking, like, if you have if we can have solutions that maybe can cut some of these things, solve some of these things, would you still use GraalVM or just stick with Java? That's my question. So we had serialization, we had stuff that before, like that we could keep some state or save some state and then go back. So how do you feel about that? It's more the question about GraalVM. Like, so I'm going back again. Okay, do you use that in production, or any of you in some kind of, or do you see it just like a big promise? I personally am using it in production. It's kind of great for what Vadym said. Like some cases, front end APIs where I have no time to wait to deliver a response. So what do you guys feel about that? Again, like on Java or GraalVM?
So
pure Java.
Pure Java for me as well. We had some experience with the GraalVM in Tundra, so we tried to migrate some Node.js Lambda functions to Java, because we had implemented them with the Node.js because of the cold start, because they are just user-facing Lambda functions, but it was challenging for us to configure the reflection files. So that was a showtime breaker for us to use the GraalVM. And so we decided not to go with the GraalVM and keep our Lambda function in the Node.js. So if there's a better solution instead of the GraalVM, and if the solution is just focusing on the pure Java, I would prefer go with the pure Java-based solution, because there are still, I think, as far as I'm not the GraalVM expert, so just correct me if I am wrong or missing some points, but still I think the dynamic class loading mechanism of the GVM is a pain point for a challenge for the GraalVM, because as you already say that, Mark, still there are tools to generate the reflection configuration files by using the statistical code analysis, or just collecting the data from the running applications. So I think that is a bigger challenge for me personally, instead of just dealing with the cold starts and just using another runtime instead of Java. But if there will be better solutions, I would prefer the pure Java-based ones.
So on this screen, you have a couple of solutions that are really kind of with plugins for AWS in many ways. Like so, maybe we can talk about that for a couple of minutes, just to say, like, my first experience with the GraalVM was with the Quarkus. So when Quarkus delivered a whole package in a plugin, so I can deploy the native function to Lambda, I said, okay, this really works. It's just one Maven call, and I have my package and I can deploy it. So it really proved that it's possible, and that they will solve a lot of these things for us. And Mark, you are really involved in Micronaut, if I understand that correctly. And the Spring Boot is also coming to a native version of some kind. These three frameworks are completely different with their different baggage. You know, so do you guys like have experience on this? How do you feel about these frameworks? How did they help you or not? Did you use Spring in the past, or?
Yeah, I definitely use Spring. I guess to dodge Spring as a Java developer is pretty hard. I think probably all of us have probably used Spring in some way or another in the past. Yeah, Spring they're going to be supporting native image in December, I think they've said, as part of their next major version releases. I think that is going to pull the industry into kind of a GraalVM becoming more mainstream. They're going to, by the work that they're doing, I think they're going to fix and highlight some of the problems. but yeah, I've seen a few of the CRaC kind of conference talks. I'm definitely not an expert. The possibility of not having to use GraalVM and having some sort of snapshot is really interesting. I would love to see more. I don't know how it's going to work with becoming part of the JDK, because I think my understanding of it is that it only supports Linux at the moment. So
yeah,
it's gonna
based on CRaC, and that's Linux.
Yeah, so I don't know what the plan is for Windows and Mac and things like that. But if they can sort out some of the kind of hurdles, I guess it's the same little thing, right? We have a trade-off between GraalVM and potential future implementation of CRaC. There will be trade-offs. Trying to remember the conference talk, but things like taking snapshots with random numbers or network connections and file handles. These things need to be considered. I guess similar to GraalVM native image.
But how do you see this whole no reflection movement? Like, reflection was everywhere. Now everyone is against reflection. So
well. I guess I find it really interesting because, if I use Micronaut, I don't actually notice that I'm not using reflection. So I don't know what sort of magic, even more magic is being produced. But, the way that I think Micronaut and Quarkus and I guess Spring as well are able to produce applications that have what we would refer to as reflection and dependency injection without reflection. Is kind of amazing and mind-blowing. And I think even if we do move one way or another from a CRaC or a GraalVM point of view, I think all of these frameworks are actually really interested in optimizing Java. And even though they're maybe taking one approach because of GraalVM, they still actually improve the JVM performance because they're not using
exactly. Without GraalVM, there is a big difference in all of these frameworks. Although there's a kind of different approach, like with Quarkus, you can actually use the existing frameworks, and they will do this analysis for you, like to map the classes. But with Micronaut, it's all Micronaut, so it's a different approach. So anyway, I can really clearly see that there are examples of Quarkus usage in AWS in some GitHub repos, and things are changing. So but how do you see that? Like we had these talks before in terms of like should AWS have one approach or more approaches? Like what is the perfect framework to start using Lambda? Because sometimes with Quarkus, I had issues using event libraries and stuff. So when I go back and try it with pure Java, it just works. And then so many like so many pieces like that can break if I just move around with all the frameworks. So what is the right approach? Is there any?
Yeah, probably my take on that stuff. No reflection movement. So the trick is, in many cases, compile time annotation processing, and then the compile time takes even longer. Yeah, so that's shifting somewhere around. Yeah, so that's the magic. There is no magic. It's just different set of trade-offs. And interesting that people are waiting for Spring, because you can work with Quarkus and Micronaut with Spring annotations as well. And then there is an annotation processor. I didn't get it work with Micronaut. They say it's possible, but with Quarkus, I have a working example with REST controller and something like that that will be proxied then to the Lambda function. And so generally you can use that. CRaC, very interesting approach, coming from very clever people from Azul, Gerrit Grunwald, Simon Ritter. I think it's a bit young technology for now. Yeah, it's very difficult to say where it's going on, but I imagine then a different set of challenges, because it's just about reaching the steady state of lambda function, just to that C2 compiler did the best, and then we can create snapshot. That's my understanding. Maybe I am wrong. The snapshot of everything, your GVM, and also the state of the application. But as far as I know, for example, the default value for reaching the steady state for functions is something like 10,000 invocations. So the question is, will the container be alive after 10,000 of invocation, or AWS will recycle it before, and I will not reach the perfect steady state? It's of course internals of AWS, if they decide to support it, how to deal with that situation. And of course, it's very promising. If I see the statistic time for the first operation with CRaC and without, then it's impressive what I see. But it takes some time, I would say 1 hour to get to the steady state. So you will be 1 hour not optimized. It's maybe a good trade-off. But then I ask myself, sometimes you package all the functions as several functions together, like you deploy the bundle of 4 functions or 5 functions, because they're just behind the same API gateway. And if you touch one function, they deploy everything. So this CRaC state should be destroyed for all the functions there, because I don't know if AWS can figure out you left that 2 functions untouched and then 2 touched. So this is the same job. Yeah, so maybe that will be also the challenge, that the state will be just lost many times depending on the frequency of your deployment. So there is different set of questions or trade-offs. Probably there is an answer, but this steady state in C2, it's just, of course, what Mark also told about, what about if you normally you don't have local files in lambda. They should be then in temp, and then it's not possible that just in one container you have the file, in another you don't have. So lambda should be simple, so you don't really run into that problem. Should not, but this open sockets open, something that may be an issue. So we probably will have also the situation that we have to carefully define then this checkpoint, then snapshot should run, and then when it should be restored. Probably will run also into compatibility issues. Who knows? It will be probably.
So does it look like that? So does it look like that at the end maybe the Quarkus and Micronaut are just what they do by default, like doing like no reflection stuff? Maybe that's like the best kind of the purest approach. Like, just we want Java. Can we just improve on that? And maybe if we can do some improvements on that we would get to something that will be really enough, for this case,
You mean Quarkus Micronaut without GraalVM native image that
yes,
they
yes,
support
yes,
behind?
Yeah. Because even with these things, like you still have, for example, you can have several functions in the same project, but like for example, Quarkus is not actually doing a tree shaking for you if you have 2 functions in it, and when you say I want to use only this function, it won't just remove everything else, from the function. So it's kind of, there are many more improvements so that we can make these packages smaller, like stuff, because very often you can have a microservice with like 10 lambdas in it, so you would like to tree shake, like, and make every single lambda to be a separate, maybe separate package to be deployed. Stuff like that would make difference. Like if you have 10 megabytes or 50 megabytes, it's a huge difference in cold starts, of course. So guys, we kind of agree that there's no like a super right approach, but I had a great conversation with Adam Bean about like lambda functions, and he said that for front end he's usually using some of the frameworks like Quarkus or something, but when you do it in backend, like, who cares? I'll use pure Java, and if I wait for like a couple of more seconds, and if I don't pay for it, then I don't care. So, like,
I think if you're interested in GraalVM and you want to, achieve that really fast cold start for synchronous workloads, I think using the frameworks is a really nice way of kind of jumping over some of the hurdles with the bundling and just getting started quickly. think that was definitely where I'd advise people to go, just because I know Micronaut more readily. You know, they have a launch page that I guess is similar to Spring Initializer, where you can, you know, select, I want an API gateway, Micronaut application, I want to use GraalVM, and I want to use AWS CDK. It will produce you an application which is integrated with API gateway, and it will produce you the CDK code for that infrastructure. So, you know, you just write the command, it deploys it all for you, and, you know, you don't have to really, you know, have a PhD in GraalVM native image to get it running. Whereas, you know, bringing in an existing application is probably more involved. But getting started in something new, I think the experience is getting a lot better now.
So one thing, I don't know if you experienced this, but this Dynamodb initialization time of the Dynamodb client is something that takes too long. I could not get it quicker, and so Quarkus and Micronaut won't help here. GraalVM native image helps, or I need whole lot memory, then it becomes quicker, but then it costs. So I think that one of the things that AWS should look into, just to cut this creation time of Dynamodb client, that we can do this in the initialization phase, because you want to reuse this, but it then adds on cold start. Yeah, that's about seconds. I don't know what is your experience, but I hear everyone is complaining, but it didn't become better.
We need super fast HTTP client.
Supporting
HTTP 3.
Dynamodb, then I need Dynamodb client of AWS SDK.
But that's all HTTP, you know, at the end. So
yeah,
I think some of it is the SDK. You know, could be improved from a performance point of view. You may or may not be familiar with the fact that the Java SDK, I think, offers now 4 different HTTP clients. So there's a couple of sync and async ones. There is a one called the CRT client, which is in preview. I find that to be the fastest. It's
since 3 years in preview, or
yeah,
I got it in fall 2 years ago.
It is still in preview. I don't think there are, you know, it isn't a problem of stability, more that they're considering if they want to add any more additional features before they make it GA. So it's definitely not a stability thing. Again, there's a GitHub issue. If you're restricted on using it because it's, you know, labeled as preview, go on there and raise your voice. But that I find to be the fastest. But yeah, I'm still looking for other reasons why making these network connections is not as fast as I would expect. So if anybody is out there doing a lot of debugging, you know, I'd love to hear from you if you've got any suggestions. And yeah, any feedback to the SDK team will be, you know, warmly received.
But coming back to your question, if I may give the Lambda function half of the gigabyte of memory, and the cold start will generally be 1 second, around 1 second, I don't care then. Yeah, that would, I can live with that. Yeah, and depending on the architecture, sometimes it doesn't matter if you have 5 seconds, but something like 1 second, and I don't care. But if it's just 6 or 7 seconds with 1 gigabyte because of DynamoDB, then I do care. Yeah, because I can lose a lot of customers. That's the situation. If we can bring this down to 1 second, doesn't matter what and how, then I can use pure Java.
Yeah, with Java, talking to DynamoDB, I think today we can get to like 1.5 seconds. But it's frustrating that, you know, these are optimizations and not just default settings within, you know, the normal ways of working. And that's what I guess I find frustrating, is that the optimal way of working should be my default way of working. And that isn't always the case. The SDK tries to be really clever and does a lot of things to make sure that it always works. And, you know, it tries to do things like work out what region it's running in. Well, you can tell it what region it's running in, and then it doesn't have to do all this clever clever scanning. And it's the same with, credentials providers and things like that. But it's a shame that that isn't the default behavior, and that I have to know about these optimizations and how to implement them.
Yeah, but
also we'll get that in Java 17 Lambda. Am I right?
We'll see.
So defaults.
Yeah, but other suggestions, like I read in the DynamoDB, you should call in the init phase like get item, because then Jackson marshaller will be initialized. Then you catch the exception, but then it's one time initialized and can be reused. That's that dirty. So so that normal Java people would say, what? Yeah, that's not normal. But yeah, but for the serverless world, it's just kind of trade-off.
But one of the comments I want to make, we're now talking more a lot about serverless, but there's Java all around, like in Dockers, in Kubernetes, and ECS, whatever, So good things with these frameworks is that they allow you to create REST endpoints. So you can deploy them the same way, like in different environments. So you can have it if you have too much. Okay, I mean, if you have too many requests, if you have huge load, maybe serverless is maybe not super perfect for every need or that you have in your application. Maybe it's better to deploy it in Fargate and then do it in a different way. Like so. The good things is that you can, for example, in Quarkus, you can use the JAX-RS, you can use your micro profile, you can use all of these technologies in the same way, and depending on the maybe if during the night you would deploy it as a serverless, and during the day you would deploy something and as a Fargate application. So it's good to have the same way of working with Java code, and then to have different deployment ways.
Yeah,
so serverless cloud uses this. Yeah, as this technology, serverless cloud, behind the serverless framework, the same company. Yeah, they provide you the abstraction. They generate infrastructure as a code, and they may run it as a Lambda or as an app runner or something like this. You even don't care and know. They price it then differently. I think it's also amazing stuff happening that gives you just another way of abstraction. Yeah, they figure out what's the best for your usage pattern and so on. Maybe it's also one step further, but you don't have too much control. Sometimes you would like to have.
Yeah, I think I'm probably biased. I see people maybe worrying too much that Lambda is a very different programming model, and it's some sort of lock-in. When I show them that the same Quarkus application can run on Lambda or Fargate, it's a real eye-opener to people. And I think Java developers, probably more so than others, have been kind of writing hexagonal architectures and architectures that abstract themselves away from the presentation and the database. So I think it's quite easy to do these swaps, and I think people maybe make a bit more of a big deal of it than
no one will lock us in, so we can. So okay, let's go to another topic. It's PowerTools for Java. It's a huge effort, like to bring some of the stuff which are not a part of the SDK, or like which are kind of also represent some good practices on how to do some stuff. So we can do all this stuff by ourselves, and we can investigate, but it's good that AWS said, okay, this is kind of this is a good way to solve some of these things, and think about this. So I mean, Mark, you are obviously involved in this a lot. So just give us like a look into the future. How do you see this? How far do you want to go with the PowerTools?
Well, pretty much all of these features that we've added have been from customer requests. So really, we are looking at how to improve the experience for customers. So the tenets of the framework are to help customers to achieve best practices easier. So this is a Lambda specific client library. So these are dependencies that you can add to your projects to help aid you in best practices. So if I think about things like logging, the logging subsystem for PowerTools helps you to do structured logging easier and to add keys and things like that, so that you can correlate logs easily and have them easily searched. The tracing functionality, enables you to use annotations on top of specific methods, so that you can add specific X-ray subsegments to specific methods. It's all just hopefully making the life of the developer just that little bit easier. And then I guess there's a slightly different on the utility side. We've actually gone a bit further with the idempotency functionality. So for anybody who's written an idempotent Lambda function, it's not a trivial case. So that utility adds a lot of deep functionality to help customers handle the problem of idempotency. Behind the scenes, it uses a Dynamodb table and some of the functionality of Dynamodb to make sure that you don't get duplicate business logic running for the same request. Having to write that yourself, I think, would be pretty challenging. We've written, or we've really investigated some of the most common error cases, and I think we've got a pretty solid implementation there. So if you're handling queues or important transactions, I'd definitely have a little look at that and see if that's something that could save you some time.
Is it safe to say that there's only one thing that you can have really idempotent in the AWS cloud? It's a row in a DynamoDB table. Can we say that that it's the only place where we can have a guarantee, a kind of distributed guarantee?
I'm probably not a good enough DBA to say that. I'm sure some of my colleagues on the database side would probably have opinions. I'm not sure.
In the core of this stuff is always there's always some kind of a conditional right to a DynamoDB table. So that's it's very hard to achieve that in the cloud. So a couple of days ago, I think that Oracle released some kind of a distributed coordinator for distributed transactions in the cloud. So it's a kind of XA transaction coordinator. I felt that that thing is kind of a part of the past, that we're gonna stop using these coordinators and stuff like that. So but obviously, not all the applications can move that fast to the cloud and think about this. But if you want to replace stuff like that, you need pieces like idempotency of this kind in the cloud. So there's a
I think with people building more distributed systems, I think you will just get systems where there are duplicates and consciously thinking about how you handle that is coming up more and more. So
So when you do stuff like PowerTools, do you have in your mind how this thing will work in GraalVM, or will it compile in Micronaut and Quarkus? And can you just test it for all the frameworks? Can you test it for all the stuff? Because you're using some techniques here in this PowerTools which are kind of maybe not work. Maybe they don't work. So
it's still very much early days for PowerTools. We don't have a huge amount of resource to test against other frameworks. We're definitely not pitching ourselves as a replacement for Quarkus or Micronaut or Spring, but where people are producing Lambda functions and want to really go from 0 to 100 as fast as possible, then if there's functionality that helps in PowerTools, then that's great. And if there's stuff that helps in other frameworks, then that's great too. But we're just trying to be really responsive to customers and to listen and to work from there. Will it work with every other framework? There's too many combinations there. But if anybody's having problems, raise an issue, let me and the team know, and we'll do our best.
maybe a question for Serkan and Vadym, like, do you have your own library that is doing all these things already?
Yeah, we have some support of some parts of the PowerTools already implemented while working at Opsgenie, especially the idempotency and the SQS batch processing and the validation parts. Yeah, so if
we all struggle with the same problems.
Yeah, if there would be such tool while I start working with the serverless 5 years ago, so that will be definitely the de facto tool for us to use initially while we are migrating to serverless.
Yeah, the same. So everybody has the same needs, I think, in that area. This cross-cutting concepts like observability, idempotency, yeah.
And the problem with our implementation was that our idempotency was based on the Redis, because since Dynamodb is more suitable solution for such case but we were using the Redis to just store the request IDs of the Lambda functions, because that was the fastest one between the other solutions. But yes, Dynamodb is definitely a better choice in terms of safety.
Is distributed better also.
Yeah.
Exactly. Okay, guys, so our last topic for today is events library, now version 4. So guys, I mean, I really had a lot of problems with this, and my recent problems were with the Cognito and so many different events there. And I hope that this time this is gonna be like the end of it, all these troubles. So we had so many times to go deep in JSON and pick stuff from JSON, and it works. But is there like a consistent way for AWS to solve this, like to have kind of universal solution for this, so you don't have to develop a library whenever you have some changes in some events, you know, like, can't you just have like some kind of a JSON definition and generate code from that? So
yeah, that would be a fantastic solution, and I think a lot of different people within AWS are looking at how we could do that. The distributed nature of AWS and how the services are created. You know, the different business units are responsible for different services, so we can move fast and innovate quickly, but sometimes the coordination is a bit more difficult. And this is one of the areas where I think you see some of the strain. So, you know, if you are working with Lambda functions and you are using some of our Java objects to represent some of the triggers, there is an AWS library which we're trying to make as complete as possible, but isn't always perfect. And the same is true of other languages. So yes, a schema would be fantastic, and to kind of get everything into that schema is a lot of effort, but I think it's a valid effort that we should do. And I think it would benefit a lot of the customers to have a really solid idea of nullability and you know, valid inputs for the fields, and it would help tool creators to make better tools. So I think there's a lot of value in it.
Because every when I look at the GitHub, you kind of every week there's kind of new kind of event coming in, and you have to do something and you have to rebuild it and then again and again and again. So like there's no end to it. So it's
yeah, and some of the problems are things like backward compatibility, because AWS Lambda functions are so widely used by so many different people for so many different things, and effectively we have a contract that we will serialize in a specific way. So now unbundling some of that serialization is quite difficult and is time consuming to unwrap in a safe way. So we're really trying to improve the serialization story for Lambda. This particular major version release will allow third parties or yourselves as individual customers to be able to specify serialization logic a lot more specifically, and it'll be more specific on how serialization happens within Java and Lambda. And people like Micronaut and Quarkus will be able to have their own serialization functionality embedded into their support, which will be awesome.
There's going to be like a serialization library in every library, like a specific. I don't know what's going on, because everyone is kind of having problems with serialization, and it never works perfectly well. But anyway, like people are expecting from AWS to maybe make even a breaking change, but then okay, if it's library v4, then things should be tested and maybe checked again if you want to move to v4. But you know, maybe if I want to pick like which library I would use, like for this I would use the old one. For some stuff that I had problems, I would use the new one. Maybe it's up to the customer to sometimes there has to be some breaking change, so it's not like that you should stick to your problems, old problems. So
yeah,
okay.
Yeah, I understand. And AWS has a very specific way of trying to minimize breaking changes where possible, and yeah, it shouldn't be at the exclusion of releasing new functionality.
So I mean, in many ways, like that's a good thing, but sometimes it can cause us like a lot of trouble, like that kind of backwards compatibility and thinking in like what was before should work in the future. But if we want to have a function that will work for like 100 years, maybe we need something like that.
Yeah,
So
Java community likes backwards compatibility. Yeah, that's the difference to JavaScript community. They have frameworks of the day. But I mean, someday AWS will release SDK Java version 3. It will be probably not backward compatible at all. And JavaScript version 3 proved that. So yeah, also interesting story. Yeah. But I'm also with you, Goran. Sometimes you need just, either you have the old baggage or you break something, but everybody should know how to fix it, or just you use versioning or something like this.
If you look at all these things that we talked about today, they're all kind of breaking changes. So there's no peace. Like you cannot have like a quiet normal development process. There's always something completely new. And now with the Serkat and all this debugging, now we're gonna like have another dependency, and then we're gonna add something new and one more tool and to do all this stuff. So there was one question from Prashant about does the idempotency work with the RDS also? I think it's the piece where they check if it's there or not. Like it depends on something that can be really idempotent, like where like the DynamoDB row and the conditional right, or if you have an index in Aurora maybe which is kind of unique, you can also have a check on that, you know. But the library is can use RDS or any other storage to keep the response from the first call that you had, you know. So if you have the same call, maybe you can have the same response, and you can store that response wherever you like, and you can implement your own way of saving this response. Am I right, Mark? Is that the right answer?
Yeah, absolutely. So the idempotency module allows you to specify your own data store. So if you want to write that in another way, you can do. But if you're talking about, you know, does idempotency work for a Lambda function which uses RDS, then yeah, absolutely. It's kind of agnostic of the implementation. It just allows you to identify similar requests and gives you the functionality to respond with the same reply for the same request.
Yes, that's I mean, there's always a question like, would you like to return the same response, or would you like to have an error or whatever? Like, it's of course it's just like it's just a tool, not the only way to do that. So guys, we are at the end of the conversation. So these are the Twitter handles for us. You can open any kind of discussion. We usually, when there's a discussion about anything Java in AWS, we always kind of jump into it, and I don't know, we kind of push each other to show more and discuss more. Of course, the community is like, it's huge in terms of usage, in terms of making comments, in terms of making noise. It's not really like people are kind of don't really want to make questions, but there should be more questions here, because these are not rules to do it in one single way. You can do these things in many different ways, you know. So please ask questions and push AWS to deliver us some of the stuff faster, and we'll deliver our applications there. So this guy, it's a two-way road. Okay. So let me check if there's like couple of last questions. Yeah, Marcin says, personally, I was searching for the official JSON schemas for AWS, and I could find the only unofficial things to do that. Of course, yeah, that's the community does a lot.
I feel you. Yeah, the documentation gives documentation in JSON examples. You know, some of the examples don't specify what the attributes are or what they mean. There's definitely room for improvement. Yeah. On those documentation pages, there are links to, you know, suggest improvements. You know, I need a schema. I don't need an example.
We need schema. Anyway, like, guys, thank you very much for joining us for this first panel, and we just opened the kind of different conversations. It's in general, there's a couple of general Java topics, but every topic reflects to our usage in AWS. So if we use GraalVM to cut cold start, to use less memory so we can pay less, we can maybe deploy more Fargate instances, but the smaller ones that can do smaller, like something called nano instances these days or something. So there's always a reason for asking something, you know, in this conversation. So if I just go back and give you a couple of things, so please try all of these things, and try Merlock, because you'll see that it's the way that you used to use Java. It's please, Mark, share the link for how to use Java 17 in Lambda. Also try deploying GraalVM and by using one of these frameworks like Quarkus and Micronaut, especially which are in production with this for a long time. And try PowerTools for Java. At least you read the documentation, which is great. I'm really, it's a different thing. It's a kind of separate world from AWS. Amazing design, everything. So it's super clear, and it shows how to do some stuff, and focuses on some of this stuff. And check the events library v4 if you want to see the trouble that AWS is in with all of these things, and how hard it is to handle all these events. And see you next time.
Thanks for the invite, Goran. See you in person next week.
Everyone.
Yeah.
Bye.
Bye.
Okay, guys, I'll close the recording now.
You will post then on YouTube, or
it was live on YouTube, and I'll share again like in a couple of days. Just pack it and share it again. In general, like the way what we see from our user group is that we get like from 10 to 15 people on meetups, like that's usually like online, and then we get maybe 200 views on YouTube in the next couple of weeks, and that's about it, you know. And then we can maybe push some topics on Twitter, but that's how it works.
That's fantastic, you know, really good. And,
it doesn't grow. It doesn't really grow, you know. Just you can't make thousands of people like in this.
You know, that's fantastic, and happy to be involved in the future. And if you need any help getting other speakers from AWS, let me know. And obviously, we're going to have some cool stuff coming up.
I mean, the Murloc is a great thing, to show. I was just trying to make kind of noise and try to steer you and say, okay, guys, do we really need this? Is it great? I mean, because I just wanted to make a discussion, but in general, people are quiet. They would, oh, there's a debugger, I would use it. Click, people just don't want to talk about that too much. They just want to use debugger. And if we can provide that kind of easy environment so they can just switch from one environment to another, who cares,
yeah, presumably it's something that can go into the application repository and you can just click it like the power tuner.
Yeah, one of the things. But in reality, when I use Quarkus, I just I'm in development mode. I just want to test stuff locally. If I can just enable Murloc, something like that, and then the things will be deployed. So things could be, if things are easy, then people would just try to use it and have this kind of continuation, from the previous world to this world, so that Murloc is a good example. I mean, I'm sorry that I kind of pushed to cover all the topics, because it
was great.
Really great to have more time to explain what did you exactly do, and stuff like that. But yeah, it's just the beginning.
Yeah, there are many feature requests coming from the community about the Murloc, but since currently Murloc is just a side project for me, but I will try to give some more time for the Murloc, especially just for redesigning its architecture, so that the others from the community can contribute to Murloc for other runtimes. For example, people are asking for the .NET runtime support, but I don't have any information about the .NET runtime, so probably I will ask help from the community. But before, I just want to provide some structure, some protocol to communicate between the local and the gatekeeper components. But anyway, I can see that there are really feature requests from the serverless community, because this shows that the debugging and the local development is still one of the biggest pain points of the serverless, and also shifting to serverless from the containers. So I think that's a good point to start working on the Murloc for me, especially.
Yeah, okay. I mean, people have to try it and then have to start using in production. And there's so many topics around, and I didn't have time for the last month, just to try it. I just wanted and never had enough time just to spend 1 hour on testing it. So, and I know that we're going to use it, in production, and to just see, okay, what's going on, to see the real data, real event, coming.
Yeah. And in fact, that was a suggestion from the Herald, is that just replicating the event to the local. So we just don't need to just forward the event, you can just replicate the event to your local while running on production. But also that might not be the valid case feasible for all the cases, because if you just execute the lambda function on your local, your lambda function, for example, should be idempotent. Let's say that if you just try to put some item to the database, there will be issues. But for example, for the read-only lambda function, you can just replicate the event to your local and then just continue to debug the lambda function. Yeah.
I have to go, unfortunately.
I also hear my child crying.
But thank you so much, and really appreciate the conversation.
We'll try again. We'll try again in a couple of months. Okay, just after Java 17 release.
You put Mark into pressure once again. Very clever. Goran, until next week in the Netherlands.
Yeah, see you.
See you
guys. Belgium.
Bye, Serkat.
Thanks.